So, generally welcome, right, to this first session in here today. It's about Spring Framework for the 2, so the title says, but it's actually a little different. It's not a what's new in for the 2. I'm going to take you on a tour through the Spring component model as it presents itself these days, kind of a modern day perspective onto the Spring Framework component model, the core Spring component model, in many of its little glories. We are going to take an annotation-based perspective, so it's all source code driven. This presentation does not contain a regular slide, just source code examples. And the source code examples really tell a story. So we're going to start from the very basics. Even if I assume that quite a few of you are familiar with the basics, I'm going to keep this very brief and kind of connected to the next stops along the tour rather quickly. The 90-minute slot here allows us to go even a little bit further. We are going to split the session in two halves. The initial half is basically a design discussion based on source code examples and slides that I'm going to start with. And in the second half of this session, we are taking yet another slightly different approach. We're going to demonstrate quite a bit of those component model pieces through live coding. So you're going to get half of the session doing some live coding, boot-based, where Stephane's going to help me, going to come up on stage then. And we're going to revisit some of the elements that we're discussing before. We're also going to show some new stuff along the way. So it's yet another perspective to take. But for the design discussion, let's get started just right now. So let's begin with the very basics. We have a Java class in front of us, right? We're building Java classes. Spring really is about allowing you to use the Java language in all its facets. You're building Java classes, you're expressing yourself using modern Java language style, which in particular includes, of course, the use of annotations, the use of generics, and as of Java 8, of course, also the use of, for example, lambdas and so forth, right? Spring is about taking Java as it is in its pretty natural way. At the same time, the Spring component model has very specific core assumptions. The core container manages instances for you. So you need to register components with the core container, or you need to allow the core container to discover components for you and to register them automatically. The components themselves are just Java classes like the one shown here. And these components have certain metadata elements in them, in the source code, describing certain characteristics, expressing certain characteristics about this piece of code, allowing the container to react to those characteristics. But fundamentally, it's initially a descriptive perspective to take. You've got a Java class here called MyBookAdmin service. It's just a regular class implementing a service interface. The service interface might have methods such as update book and others down there. Let's just assume that that's the case. You don't have to implement the service interface, of course, but many Spring apps traditionally do have very consistent interface layers. Right, now what kind of annotations can we see here? There's the add service annotation on top. Add service is a stereotype, a kind of categorization of the class. It's generally called the add component stereotype model. Add service is already a specialized one. It's kind of meta-annotated with add component, side note. But generally speaking, it's one of the out-of-the-box stereotypes. You're sticking that on top of your class at the class level to categorize this class as a service class. This is a formal declaration. So the class is not just named service, something service. It's formally categorized as a service class. So this add service annotation actually tells you something about your piece of source code. When you read your source code, when you revisit this class in an IDE or even on GitHub in any kind of view where you take a quick look on the source code here, this add service annotation immediately tells you something about what kind of class you're dealing with. Another kind or category of annotations here is at auto-wired, found at the constructor level in this example. This is a dependency injection annotation. The set of dependency injection annotations in Spring allows you to express a demand for references to other components. So fundamentally, you're saying, this MyBookAdmin service has a constructor here, and in the regular case, I want this constructor to be automatically wired to an account repository bean, account repository component that's also around in my context. You can, of course, satisfy this requirement by direct construction, right? In a unit test, you would just say new MyBookAdmin service, and you pass in the account repository reference, maybe a mock object. But in a container environment at runtime, these components would typically be created through container algorithms, and the container would just say, is there an auto-wired constructor? This is the one I'm supposed to use because it's declared as to be auto-wired. So I'm going to take this constructor, going to look at the parameters, going to find matching components that are assignable to this parameter. If there's a unique match, I'm going to inject it here, invoke the constructor with that reference, and all is good. The container is then going to hold on, of course, to the MyBookAdmin service instance, and is going to manage the scope for you, and is going to expose it to any other component wanting to talk to a MyBookAdmin service. Another kind of annotation can be found at the update book method here, at that level. It's at transactional is a very common example for a declarative annotation that allows you to tap into a middleware service, into some kind of interception that the container is going to do for you at runtime. But that's already actually a step too far. Initially, this is a descriptive element. Update book, that method, the update book method, is transactional. You can actually read those elements. So the idea is that the Java source code here, this piece of source code, is pretty self-expressive. You can actually look at just the core elements of that Java class, the names of the class, the names of the methods, of course, but in particular also the annotations found on this class, and kind of just read them in a little bit of a backwards way, of course. The update book method is transactional, but it flows quite nicely. And semantically, it tells you something about that method. It tells you about some transactional demand, some transactional behavior that this method is expecting. So it's supposed to be wrapped in a transactional boundary. So that's kind of this design perspective that we apply when we design those elements for use in application components. Of course, there are many more annotations. There's even one more shown up here, the @lazy annotation, just suggesting to the container that it may please lazily create a shared instance on first request and not on startup. There are many ways to guide the container, right? Those annotations are not instructions. They are declarative metadata elements allowing the container to reason about them and to react to them at runtime. All right. Now, this is actually a bit of a personal favorites tool, by the way. So we're not going to do a comprehensive discussion of each and every core container feature here, by no means. It's rather a little bit of a selection of favorite features. And one of them is coming up right now. It's the composability of annotations. You may, of course, just use out-of-the-box annotations in Spring. Just use them directly wherever you see fit in your code base. But you may also go a step further and build your own annotations. An annotation is just a regular type in the Java language. So just declare a public interface of some annotation. And in this case, it's a MyService annotation. The MyService annotation is now being meta-annotated. Those are just annotations on your annotation type called meta-annotations, where typically standard Spring annotations are to be found. So it's a custom MyService annotation, meta-annotated with Spring's standard service, suggesting a default scope of session, suggesting a primary role. In case of the several type matches, this one would be preferred, and even a default transactional rule. So this MyService actually expresses quite a bit of stuff in just one combined annotation. this combined annotation can now be used on any kind of class, any number of classes in particular, in your code base. So you may have dozens of classes in your code base annotated with @myService. And every time you're saying @myService, what you're really saying is the combination of characteristics above. From that perspective, this is a shortcutting model. You could see it as a shortcutting model, combining several annotations into one sweet, concise custom annotation of yours. But it's actually more than that from the core design idea behind it. It's a way to choose a custom annotation name and to have some semantics attached to it, some role attached to it in your code base. @myService might not be the most expressive name in the world here, but you could use a name that has a more specific meaning in your code base. @account service, @order service, maybe identifying the module or the layer, the part of your system that it is in. Maybe a specific kind of service, a service that's, for example, session scoped by nature, a user service of some kind that's to be stored on a per-user basis. All of those characteristics can be condensed into a custom annotation name of yours. Put some Java doc on top of it to say what this annotation is supposed to mean in your code base, and use meta-annotations to formally describe those characteristics using standard Spring annotations. And you've got a pretty sweet model in the end, in particular for larger code bases, where those annotations can be used for guidance purposes. You can kind of draft a set of annotations here. The team agrees on a set of annotations and would consistently use those annotations in a wider code base. So it's also about enforcing consistency, about enforcing specific combinations of characteristics across the code base. So this innocent little composable annotation model can actually be exploited to quite some degree. It does way more than you would initially think it can do for you. So let's just explore this a little further, just to give you an idea of what this model can do, even on a fine-grained basis. This is a custom scoping annotation on top, called MySessionScoped again, right? I'm not trying to be creative here about the names, but of course, in practice, by all means, please use a proper name, right? But this one is called MySessionScoped. And it's not just saying @scope_session, being meta-annotated, kind of hard-coding this scope name, which is a value in its own right, because when you use @mySessionScoped, you don't have to give a string name for the scope name anymore. The scope name is hard-coded in the meta-annotation. You can't get it wrong, right? It's a type-safe way of saying I want session scope. It goes even further. It actually declares an attribute. And this attribute is meant to override the same named attribute in the standard scope annotation. So proxy mode has the same name and type as the equivalent attribute in Spring standard @scope, and semantically overrides it. So it's a convention-based overriding model at this point, which is actually a pretty sweet spot then. The session name is hard-coded, so a user of MySessionScoped cannot influence the session name, the scope name, sorry, the scope name session, but the user may choose the proxy mode. The proxy mode is no by default, but you may choose to have a scoped proxy instance. In Spring scoping model, you may choose to have an interface-based proxy here or a target class-based proxy, not giving you the raw scoped instance, but rather a shared proxy that delegates calls to the actual scoped instance. This is still left open to the user of your custom annotation. This may even become more obvious with the example below. My transactional down here is a custom transaction annotation. It's meta-annotated with @transactional, has a standard rollback rule associated with it. Doesn't actually do much more than this, but it declares an attribute. It redeclares an attribute from standard Spring @transactional. And the chosen attribute here is read-only. And, well, this works just like that, right? @myTransactional, read-only true or false is how you would be using it. But that's not so different from using Spring's @transactional itself, is it? Well, the advantages here are really subtle. This custom annotation just redeclares one selected attribute from @transactional, not all the others. So a user of @mytransactional may not change the rollback rule, may not change the propagation behavior, the isolation level, or the timeouts. All of those things are not opened up here, are not redeclared. You cannot set them as an attribute. Just the read-only attribute, because the designer of this custom annotation wants the developer team to focus on the read-only nature of the transaction and forget about everything else. And in addition to this, the read-only attribute is declared without a default. If you just compare the two annotations, this one above has a default. You have to specify the proxy mode. The annotation below, read-only, does not have a default, which forces the user of the @myTransaction annotation to reason about the read-only nature. You have to say read-only equals true or read-only equals false. You can't get away with just ignoring it. So this is a way to guide developers, a larger developer team across a larger code base in a very subtle, very specific fashion. So custom annotations, whether it's stereotypes or very specific annotations, such as for scoping or for transactions, or anything else in Spring, is a really, really powerful model. So a very up-to-date variant of this, introduced in 4.2, is being a bit more explicit. In case you were wondering whether this convention-based overriding may not lead to some problems, right? Accidental overrides or somebody not really being aware that this is an override. You may be a little bit more explicit and use the @alias4 annotation saying this proxy mode here, this scope proxy mode attribute is an alias for the proxy mode attribute in the scope annotation. So the @alias4 variant is not convention-based anymore. It's very explicit. It immediately points you to the attribute that you're overriding here. And it has a couple of advantages. If you look at the variant with the scope proxy mode above, we shortened the attribute name to mode here because there's no need to use the same name anymore. It's declared to override the proxy mode attribute in scope anyway, so you can use any name for the attribute here because you formally point to the original attribute. You don't have to use the convention of applying the same name. MyTransactional below does the same thing, but it does not rename the attribute. In this case, you could even just skip the attribute declaration and just point to the original annotation that you're overriding an attribute from. This is also pretty useful in more complex composed annotations where several meta-annotations are being used, like the stereotype that you initially had, this my service annotation, where there are plenty of Spring annotations are to be found. At that point, it really does make sense to be explicit if you're overriding an attribute, just from a very specific annotation, very specific attribute name. All right, so much for the power of composability. Just as a side note, this works for almost any annotation in Spring. You can even have custom @bean annotations, custom injection annotations. As of late, even custom annotations in WebMVC. So this composability idea, the same reasoning that we applied here, works for almost any annotation in Spring. All right, but let's move on from the composability to just a quick discussion of configuration classes. I suppose you have been seeing this. It's, of course, very central to boot, and it's everywhere, right? But from a design nature, configuration classes are just regular Spring component classes with a specific stereotype. They say @configuration, identifying the kind of class that this is. But they're actually managed like regular Spring components. They can be found through component scanning. They are being instantiated and lifecycle managed just like any other component in Spring. However, they have a specific role. They are meant to contain @bean methods. @bean methods are themselves declaring beans. So it's actually a way for expressing bean declarations with custom factory methods in a pretty idiomatic Java style. This MyBookAdmin service method is being discovered by the container through its @bean declaration. The container will just create a bean definition for it, default scope session, and every time a new instance of this MyBookAdmin service is being needed at runtime, every time we have a new session with no instance in it yet, the container is going to call this factory method in order to obtain the instance. So instead of calling a constructor of a regular component class, we're calling a factory method on a configuration class, building that component instance for us, which is, of course, a pretty powerful model in its own right. You can use builder APIs, target factory methods in some third-party API, or even lookup APIs here. Configuration classes can do way more. And in Spring Boot, of course, you're seeing configuration classes on steroids, right? The full power of configuration classes becomes very apparent in Spring Boot. And the @enable annotation above, for example, is one of those things where Boot really thrives. @enable transaction management, @enable caching, @enable discovery client, as we're seeing in the Spring Cloud demos. Those are all like sweet little shortcuts pre-built for you, setting up whole pieces of infrastructure based on some conventions. And all you need to do is to enable it through one line of annotations on a configuration class in your system. So this is the gist of this powerful configuration model. If you want to learn more about that, Boot would be a great entry point, or if you want to see more of that in action. For our purposes today in this session, just some rather unusual variants that you're not seeing that often. Configuration classes can have base classes. This is actually, this has been the case for quite a long while. So this MyApplicationConfig extends a base config class, MyBookAdminConfig, which has this @bean method where the @bean method actually points to some other bean method because it calls a bookadmin data source in the middle of its body. This might be an abstract method maybe on this base class, or it has a concrete implementation that you may override in your configuration subclass. So @bean methods can be overridden. @bean methods are regular Java methods. And in a configuration class hierarchy, you may choose to make good use of this. Declare abstract methods, declare base implementations that specific other configuration classes, extend and override. So this is pretty straightforward. It's basically standard Java inheritance applied to configuration classes and working as expected for you. A pretty interesting twist, a more recent feature, is the use of default methods. We are applying the same reasoning here. We're saying this is a standard Java 8 language feature. Interfaces can have default methods. So a default method has a method body. It lives in an interface but has a method body. It may not access any state because an interface cannot have fields, but it may refer to other methods declared in that interface. So syntactically, this is all you would need to do. Declare an interface, and instead of a regular method definition, you would use the default keyword to declare a default method on an interface. From our perspective, this is slightly unusual, powerful but unusual. Our main design concern there was, what are we doing if we encounter that sort of method and it's annotated with @bean? Because it's a standard language feature. We want to enable standard language features. Configuration classes don't really have that many special rules attached beyond the Java language itself. So as of Spring 4.2, we are detecting those. And we are registering those just like any other @bean method. This allows you to compose, for example, this custom MyApplicationConfig class above, implementing several configuration interfaces, which have a couple of @bean methods on them, implementing several interfaces. Oops, the particular strength. In this case, it's just a refactored variant of the previous example. You could use a base class here. But at the point where you implement several configuration interfaces, you've got multiple inheritance applied. You can inherit @bean methods from several interfaces with some default methods on them. They may not access shared state at that point, but they may call shared methods. This is a pretty powerful model for say, more complex configuration scenarios where maybe within your corporation, several teams are building configuration artifacts, and there are a couple of base artifacts that are supposed to be reused. And in a concrete microservices project, you would build a concrete configuration class that just takes a couple of those pre-built artifacts and combines them into one configuration class to start with. So it may look slightly unusual, but it works just fine, the same way that default methods work in Java 8 overall. So we're taking this pretty far, in particular, not just the configuration class story, but also our use of Java language features, language features in particular. Okay, let's move on in a bit more fast-paced fashion, just to giving you an idea of everything you can do here, if you need to do it, right? This is not all features here that you need to use on an everyday basis. Those are features that you're using if you have a specific problem to solve, a specific arrangement to achieve. And the details of the Spring component model here allow you to go as far as you need to go. You can keep it simple for large parts of your code, right? But in specific places, some of those features are really life saviors. So one specific feature here is the ordering of configuration classes, also a new feature in Fodder 2, where if several configuration classes are being found through the use of component scanning typically, you have no guarantee about the order of detection, right? A component scan goes into the class path, finds components by stereotype annotation on top. It says like, oh, this is a Spring component or a Spring configuration class. I'm going to register this class, this class, this class. But the order of the class path scan is not well defined. Depending on which JDK you're running on, which application server you're running on, you might get a different order. That might not make a difference in a typical application, but in some cases it does make a difference because you want some pieces, some beans to be initialized first, or in this particular case, you want some beans to override other beans because overriding of beans by name is a Spring feature that's been around for a long, long while, and it's particularly important to do it in the right order, right? If you want this special book admin service to override the other one, because the method name, the bean name is the same, then you'd better register the special book admin service up there, that configuration class, after the other. If you are using component scanning, one way of achieving this would be to assign orders. The add order annotation is pretty common in Spring, can be used in many places. We are also going to see it reappear in just a bit. Can also be used for configuration classes. If there are orders assigned, we're going to order them for you before we actually activate, register, instantiate the beans declared by those annotations, declared by those admin methods. Right? So things can be ordered in Spring. If you need to have a deterministic order for things, try to use the add order annotation. We're going to revisit this in just a few minutes. So, flipping the perspective a bit again, let's look at injection points. Injection points are the place where you demand access, demand references to some other components. Typically declared using the add auto-wide annotation, with add auto-wide to be found on a constructor here, saying, I want, like for this MyBookAdmin service here, I want a my repository of account. So let's assume my repository is a custom interface of yours, seems to have a type variable, a generic type variable, which is being substituted with account here. So you don't just want any my repository, you want the my repository of account. As of the Spring 4 generation, we are taking this into account for the purposes of type matching. So we're saying, you declared a very specific signature here. You gave us a very specific hint about the type and even the generic types that you are trying to obtain. We are going to look at our bean definitions in the context. We might find the two admin methods above. I mean, typically, of course, in a different class, right? In some configuration class, in a different part of the system, in the configuration part of the system. And let's assume there are two methods, two admin methods, declaring my repositories. One declares a my repository of account in its return signature. The other declares a my repository of product. As of Spring 4, we do the obvious for you. We are going to select the my repository of account variant above and inject it here. In previous Spring versions, you would have run into an exception that says, sorry, no unique match. There are two my repositories in your context, my account repository and my product repository. Can't resolve it for you. Give me a more specific hint. Give me a qualifier. You don't have to add a qualifier here. No need for extra metadata. The type declaration in the parameter is expressive enough. This is also part of our general design mission here. A Java language feature, generic type declarations. If they are expressive enough, let's not insist on metadata. No need for adding extra annotations if the type declarations themselves are expressive enough to solve the problem. So this is part of that story. Generics-based injection matching, a completely new, overhauled algorithm trying to do the type matching for you in the Spring 4 generation and having, for example, this particular benefit here. Well, let's revisit order for a moment. We can take this a little bit further and use collection injection. We can say, my book admin service wants a list of my repository of account. So you can take this even into deeper nesting levels. What you're really saying here in this constructor is you want all my repository of account beans in the context wrapped up as a list and injected into your constructor. So Spring is going to look at its bean definition, it's going to find all the my repository of account matches, and it's going to accumulate them into a list. And this is where ordering comes in again. If you're specifying @order annotations at the bean declaration level above, in some of your configuration classes, we're going to pre-sort them for you. You're going to get an ordered list sorted along your order declarations. Otherwise, you would get just the order of registration of beans, which, as we said in a component scanning environment, might not be predetermined. So that's actually pretty sweet. And you can take this even further. We're going to see a couple of variants of what those parameter declarations can do. This is a lazy injection point. Look at the constructor again. My book admin service has a my repository of account, and it says @lazy. At the parameter level. It uses a parameter annotation to say this particular reference here, I'm okay with it being a lazy proxy. I don't need the fully initialized instance here. I'm okay with just something that I can call later on. And this is exactly what the container is taking into account. It's saying, oh, okay, we don't need to fully instantiate this my repository of account there. We can actually create a proxy that, when the first method call comes in, will initialize the target bean. Then and only then, not before. So in combination with an @lazy marker on the target bean declaration, you can achieve a degree of laziness that wasn't quite there back in Spring 3. This is also a rather recent feature. Lazy declarations at the injection point. This can be used for resolving circular reference scenarios or startup timing scenarios where some components might not be fully initialized because they are asynchronously initialized, drivers, access to third-party systems that might not be there yet. So these lazy references can solve quite a set of problems. And the design idea behind it is simply the signature, right? All that you're saying is this little innocent @lazy annotation at the parameter. And it's even telling you something. You can read it, right? You want a lazy my repository of account here. So it's also quite readable because many of the things that we're doing have these two roles. Readability in the source code and expressiveness in terms of the container reacting to it at runtime. All right. Another variant, which I'd just quickly like to mention here, is that we support, in Spring, we support quite a set of standard annotations coming from the JavaX packages. We are typically showing the Spring annotations because they tend to be the more powerful variants. They tend to have features way beyond any equivalents in the JavaX namespace. But at the same time, you may choose to use standard annotations and Spring automatically reacts to them. You don't need to register anything, just use them. Just bring them onto your class path, declare them on your components, and Spring is going to find out about them. So this little example here just takes a couple of the ideas that we've seen before and expresses them using standard annotations. It has a standard @managed bean stereotype above, cannot be composed, doesn't really have any extra features, but it's not very expressive either. It can't influence the name, but it's a way for a component class to be detected in the class path, and it comes from the javax.annotation package in JSR-350. The constructor is actually the more interesting part here. The constructor uses JSR-330's add-inject annotation, coming from the javax.inject package, which is a pretty immediate alternative to add auto-wired. And it's a pretty common annotation. So in some code bases, you may choose to use add-inject consistently. You could mix and match it. So you may also mix and match add-inject and add auto-wired, even in the same class if you insist. But it's not really recommendable. You typically have a policy, set up a policy for a specific code base saying, we use these kinds of annotations consistently in our code base, and add-inject may be the annotation of choice for injection purposes. The signature here is also pretty powerful. We support quite a bit of the resolution flexibility for add-inject as well. It's almost equivalent to add auto-wired in many ways. If you want to use standard types only, no Spring imports in your component classes, you can even declare lazy access. The add lazy annotation is not the ideal choice then because it's a Spring annotation. But in JSR-330, in javax.inject, you have the provider interface, which can be used for the same purpose. If your constructor says, this parameter here is supposed to be a provider of my repository of accounts, then that's exactly what you'll get. You get a provider wrapper, which has a get method. And when you call the get method, that's when we're going to obtain the my repository for you, which is a way to express lazy initialization, not through a proxy, but through a wrapper handle with a get method, JSR-330's style. And some oldies but goodies are also add post construct and the more important add pre-destroy, which can be used to declare init and destroy methods. Coming from the javax.annotation package introduced in Java 6, been around for quite a bit, automatically detected by Spring for you on any kind of Spring managed component. In this particular case, we're just going to call this shutdown method for you whenever we take a bean instance out of service here, whenever we shut down, or in the case of, for example, a session scope bean, whenever the session ends. All right, let's have a little bit of Java 8 in here again. This MyBookAdmin service variant is based on the standard annotations shown before, but has a little Java 8 twist. Again, look at the signature. It's now declared as MyBookAdmin service constructor with a parameter that's declared as optional of my repository of account. Optional is java.util optional, and there's a bit of a debate about the use of optional in your code. We're not enforcing it at all, but if you're using it, if you're declaring such injection arguments, injection parameters as optional, we're going to resolve it for you. We're going to look for a my repository of account. If we find one in the context, you're going to get an optional handle with that instance inside. If there's no my repository of account, you're going to get an empty optional instance. And with optionals API, you can then call isPresent or all the optional variants to continue from there and react to the presence or non-presence of the instance. This is basically a way to declare optionality. In the Spring's add auto-wired annotation, you could say required equals true or required equals false. In the case of false, you would get a null reference. This is a little bit more expressive, and it works with add-inject, where there's no required attribute. The optionality comes from the type declaration, not from an annotation or annotation attribute. And you don't get a null reference. You get an optional empty handle, which in Java 8 can be idiomatically used to continue from there. So optional support, just a little hint here, works across the framework. You can declare request parameters in Spring MVC as optional. You can declare almost any argument parameter that makes sense in Spring's component model as optional, and we're going to resolve it for you. It makes particular sense for dependency injection flow. All right, while we're there with Java 8, just a quick perspective onto the formatting package in Spring. You may have seen this in action before in combination with Spring MVC in particular, where we are binding string values onto typed fields or rendering out typed fields to a text representation, whether in an HTML page or in any other kind of text format. Spring's way of expressing this is typically the @datetime format annotation or the @number format annotation or similarly minded annotations. Custom formatting annotations assigned to the field where if there's no more specific information given, the binder in Spring, the binding component, would look at those annotations to find out about the format of binding, and the format of parsing a text into this field, and also the format for rendering it out to a string. So that's Spring 3.0 era functionality. But in this particular case, we are applying it to a Java 8 local date and Java 8 local datetime field. So we are using the java.time package in Java 8 and declaring the fields as such. As of Spring 4, this is automatically detected. Spring knows, the framework knows about those types and can handle those types and can apply, for example, this datetime format pattern on the last contact field and produce a local datetime instance for you automatically. No need to register anything specific, just run on Java 8, declare your classes that way, and it's going to work. An interesting little twist is the other field, the birth date field. Birth date is a local date, and the intention is to convert it and render it as in the ISO date representation. Well, it turns out that we don't actually have to add an annotation for this, which is why it's commented out. So you can just drop that line because the field type is expressive enough. That's one of the strong advantages of the new java.time package. Local date, local time, local datetime, zoned datetime, those are very specific types. They tell you the exact role of that object. Whereas with java.util date, it's kind of, what is it, right? Is it a timestamp? Is it a day plus time, a time within a day? No one knows. Java.util date was this kind of very vague type. But local date, local datetime, and co are very specific types. And if those types are expressive enough, they have a default representation. For local date, it is ISO date. For local datetime, it is ISO datetime, and so forth. If you're happy with that representation, there's no need to add a formatting annotation. Just declare your fields in that specific type, and all is going to be good. This works for the Java time package in Java 8. It also works for Joda time. So this is not exactly a brand new feature either. You can do this sort of stuff with Joda time in Spring 3 already. As of Spring 4, it also works for the Java 8 java.time package. And as of Spring 4.2, we even support the new monetary amount type coming from the javax.money package in JSR-354. You may use the same kind of arrangement with these brand new, pretty useful common monetary amount type representations. So there are two key types in JSR-354, monetary amount and currency unit, both understood by Spring out of the box if the JSR-354 API is on your class path. So no need to register anything, it's just going to work automatically. And we apply the same reasoning again. If there's no formatting annotation, we go through the default formatters in the JSR-354 framework. There's a default formatting arrangement there, which is customizable on a service provider basis. But if you are actually declaring a specific format to use for parsing and rendering, we are of course going to take that into account. So if there's an @number format annotation with a pattern, that's how we're going to parse this particular field for you, going to produce a javax.money.monetary amount for you. So we apply the same idea not only to datetime types, but for example also to the new monetary amount type in JSR-354. So talking about Java 8 stuff, a couple of nice twists. You may have seen @async methods before. @async is a way to declare a method such that you're just calling it and it's being wrapped up in a callable, passed onto a pre-configured thread pool that you associated with this, and we're going to return either nothing or a future handle for you. And these examples here show a future handle. That's Spring 3.0 era functionality again, but the example in the middle here is actually somewhat new, and the one below is also only works in Spring 4. We are making use of Java 8 features here. You may declare the return type of your async method as a Java 8 completable future, which is a way more powerful type with composition methods on it. All you need to do in order to get a completable future is to declare your return type. Spring detects this, builds a completable future for you, and you can take it from there. When you invoke it, you get the completable future, and the caller would just use this handle to track the execution of the target method. And implementation-wise, it's also pretty nice because completable future has a completed future convenience method where you can return a pre-built result object wrapped in a completable future using standard Java APIs only. No need to use any custom wrapper types. This async result above is a Spring wrapper type. The addScheduled example below is actually also Java 8 specific, because just have a look at the double declaration of addScheduled here. We are associating two cron triggers with this single method. In pre-Java 8 rules, that wasn't actually possible. You could not declare the same annotation type twice on the same artifact, on the same member. As of Java 8, annotations may be declared as repeatable, and this is exactly what we did with addScheduled. There are quite a few annotations in the Spring codebase that are declared as repeatable now in Spring 4, which allows you to redeclare them and just associate two triggers in a very convenient, very readable way. The alternative is to have like a container annotation addSchedules, which has a nested array of addScheduled, which I don't even want to show it. It looks ugly. But you can do it on Java 6 and 7, but this is way nicer if you're on Java 8 and works out of the box, since Spring went that extra mile and did declare its out-of-the-box annotations as repeatable where that is semantically appropriate. All right, so to wrap it up and actually switch to the live coding mode here, a couple of just examples that I'm going to show you very quickly here to get a design impression. Those things are going to reappear, most of those anyway, in the live demo. This is Spring's controller style in WebMVC. You're probably familiar with it, right? A stereotype, type above, in this particular case, the new address controller annotation, request mapping methods where HTTP methods are to be bound to it, and just method signatures that are going to be resolved against the incoming HTTP request, where you may extract parameters, headers, cookies, or here path variables from the incoming request in a pretty nice, pretty convenient way. There's even a little Java 8 twist here again, because the path variable declaration here, notice that we are not redeclaring the path variable name. We're going to use the method parameter name for you. So we're going to introspect it. We see a long parameter of name ID that's declared as a path variable, and the framework figures it out for you that you probably mean the ID parameter in the request mapping path above. That's actually not so trivial to do at runtime, because method parameters in Java are traditionally lost at runtime. Parameters don't have a name at runtime, historically. They just have a type and an index. The way that we are handling this on Java 8 is that all you need to do is to use the new Java 8 -parameters compiler flag. So if you want to use, in particular, the Spring endpoint model in its nicest fashion, make sure that you're compiling your code with the -parameters compiler flag, which makes the compiler include the parameter name information in a dedicated section in the class file. And we are able to resolve it from there. On Java 6 and 7, you can achieve the same by combining with -debug. We are going to parse the class files for you and going to look at the debug symbols and going to find out about the parameter names from there. So you can do it in Java 6 and 7 as well, but it's a first-class feature in the JDK compiler as of Java 8. So this is Spring's endpoint style. We are using it against almost any endpoint model. For example, if you're processing STOMP messages coming in on a WebSocket channel, very similar model. Controller stereotype, two kinds of mapping annotations, message mappings and subscribe mappings against the STOMP protocol. An incoming message is going to be bound to the method that you associated those metadata with, and the methods may declare parameters that we are going to resolve for you by type. A principle is the security principle. We know about that, so you don't have to declare anything. We're just going to inject it for you. And the trade object is a payload object with no extra metadata given. Similar to Spring MVC, we would just take the incoming message and convert it into this straight object for you based on the registered message converters. So in Spring 4.1, we took this, we applied the same model to JMS endpoints. So just looking at what this design-wise looks like, it's a JMS listener annotation. You're basically binding an endpoint method to a specific JMS destination, either very simply, as shown above, or with very elaborate configuration, as shown in the example below, depending on your need. The point is, the JMS listener annotation allows you to be as expressive as you need it to be. Right? If it's just a regular registration against an incoming queue, use the simplest possible form. If you need to fine-tune the endpoint listener more specifically, there are plenty of fields allowing you to do that, plenty of ways to add selectors, to add concurrency levels, and so forth, and to give information about the response destination, because those methods are not just allowed to accept an incoming payload object in a pre-converted form, they are also allowed to return a payload object that we're going to turn into a response message and send back to the reply destination given, or to the send to destination given if that annotation is specified here. So the same kind of design model, very similar not only to the general Spring Component model ideas, but also to, for example, Spring MVC endpoints or STOMP endpoints on WebSockets. In 4.2, we also have event listeners. Again, at this point, it's probably obvious to you, the same endpoint style. You could almost guess it. It's a set of methods, endpoint methods for event processing, and at event listener annotation, we're going to look at the signature. An undeclared object is typically the payload object of that event, which we're going to extract for you automatically, and a couple of attributes that allow you to fine-tune the endpoint's behavior. For example, assigning an endpoint condition that kind of filters the incoming events and only passes specific events into that particular method. So some of those, or most of those endpoints we're going to revisit in just a bit, including cache processing. So just a quick design perspective on how we handle caching, declarative caching. It's a regular Java class, regular Spring Component class. When you want the invocation, the result of a method to be cached, just add the @cacheable annotation. And we're going to take the incoming parameter, compute the cache key from the declared parameter that comes in, and we're going to use the return object as the cache value. It's all based on the method signatures. The modern Spring Component model is very, very Java source code centric, reacting to method signatures, parameter and return type signatures. There are also cache put and evict variants, but let's skip that for a moment. In favor of the JCache variant, we support the standard JSR-107 caching annotations as well, as of last year, where when the JSR-107 got finalized. This is basically an immediate equivalent to the Spring annotations. Just use them, have them on your class path and use them. Spring is automatically going to react to them, no extra configuration needed. The terminology is a little different. So what we call cacheable in Spring is called @cacheResult here, and a couple of differences with the put and evict methods as well. Spring's caching annotations have a few subtle strengths, and they are a little bit more in line with the terminology of Spring's annotations, the readability of Spring's annotations overall, but it's your choice. Just like with standard injection annotations at inject that we discussed before, you may choose to use the standard caching annotations from JSR-107 with Spring. The choice is up to you, and the configuration is exactly the same as when using the Spring annotations. We make it as easy for you as possible to use standard annotations when you choose to do so. All right. So much for this little design discussion tour. At this, we are going to switch into demo mode now. Just 2 pointers to other sessions. We have immediately following after this one, probably in the same room, I'm not sure, different room, whatever. Look it up. I know the rooms are hard to find in this venue. But anyway, there is Sam's testing with 4.2 session. And tomorrow, same time, 10:30, we have Ross's Spring MVC 4.2 session, where it's a more in-depth kind of what's new coverage of new features in Spring MVC processing in particular. All right, so at this point, let me invite Stephane up to the stage. And we're going to do a little bit of demoing for you now. So, your laptop, man. Audio for this one? Try it again. Could somebody please activate that micro? Thanks.
Anyone?
Otherwise, I have to do all the talking. At some point, my voice is going to be gone. Do we have an audio technician in the room? Or could somebody just make a technician appear, please? Out of the blue. Yeah, it's turned on, but it's probably somebody needs to press the button back there to activate the channel. So do we have anybody in the room with the ability to call a technician, please? We are going to continue from here, and I'm going to do the talking for the moment, but it would be nice if that mic was also working. Okay, cool. Yeah, but we're not going to do a break for you here. Let's keep it rolling. So screen works at least as far. So we're going to demo a couple of those concepts for you. Well, based on the latest version of Boot 1.3 and 5. And the starting point here in a typical Boot application is recognizably Boot, right? The Spring application starter. I need actually to follow, that's Stephane's part actually, I'm talking about here now. I'm bearing the micro. So, well, we have we took a couple of, impressions from the slide deck. So we have a book repository here, where we're registering a couple of well-known books in this repository. So far so good, really. This is the book's endpoint representation that we'd like to have here. So it's pretty much a modern-day Spring Boot app with a JSON representation on an HTTP endpoint. Is this too small for you guys in the back? Yeah. It's very, yeah. Can we do anything about this? Just to.
That was the same thing yesterday.
Yeah, we can only try to improve the font size in the editor for you, right? So anyone turning the mic on? It would really help. So this is the created handler with it's going to get an event listener method, right? If I remember the flow correctly. So the first thing we're going to show in action in a Spring Boot context here is the use of Spring Framework 4.2's at event listener model, but we're actually going to use it with a Spring Data event. So this after created event is being published by Spring Data, if you're using it. There's several parts of the Spring Data universe. And at event listener in Spring 4.2 is designed to process any kind of application event. In this case, we choose to receive the actual event handle. So the original application event object. And all we wanted to do is to, well, spit out some logging, right? When invoked. Event listener methods may sit on any managed component class. So one thing to pay attention to, please, is whether a particular class is actually managed by the Spring container. You may, of course, have any number of classes in your system, domain classes or other classes, which are not managed by the container itself, right? So putting at event listener methods just on actual Spring managed component classes is a good idea. The container is going to find them then anywhere. Events are about decoupled communication between different components in the system. So just publishing them on one end and having them processed in a pretty remote corner of your application, that's what events are for. All right. this is the book controller, right? The HTTP endpoint arrangement that we have with a long path variable. Should be pretty obvious what we do. We actually do use a little bit of hypermedia here in terms of how we handle the response links. And well, any noteworthy elements. So we have an exception handler, which is also a declarative way of a kind of an escape hatch if the request cannot be properly bound. We have an exception handler model in Spring MVC where those requests are being delegated to, and you may choose to use a specific response status to send it back with. So.
And processing is slow, you should say that.
Processing is slow?
Yeah.
Yeah, processing is always slow. So
yes, let's fix that. We need to fix that.
Yeah. Okay, let's fix the processing. If we don't get a mic, I'm going to hand the mic over to him. But it would actually be preferable if we just had the damn mic activate. Yeah, how hard can it be to turn on the mic? Sorry, but yeah. It's because at that point, yeah, I mean, we can hand over the mic if you want to, but sorry, 30 seconds of noise.
All right. Hi, guys. All right, so we had this very simple application managing books, and I quickly show you how you can add an event listener. So basically registering a service and creating a method any way you like, passing an event to it, and adding event listener, which will in turn create an application listener behind the scenes for you. Like we saw in the slides, if I would have a return type to that, then the processing of the event would trigger the sending of yet another event that can be processed by another event listener if necessary. So we've seen that when I post this URI to create a new book order, it's being slow, so it's actually calling this book order service. So let's see that book order service is doing. So it's a transactional operation, taking the book ID and customer ID for the sake of the demo, whatever, retrieving the book, creating a book order, saving it, and then verifying the book order, and verifying the book order apparently do some stuff. And you probably need an adult if you want to do that yourself. And return the book order status. So that's basically the thing that's taking some time. So what I'm going to do now is to restructure that code to show you how you can separate the processing of the verification to a different component. And for that, I'm going to use a message queue. So the first thing I'm going to do is, is to add a dependency to it. Probably should be better that way. So in the Spring Boot world, for those who know, the concept is to add something that starts with Spring Boot starter. So I'm going to use OrnetQ for the sake of this demo, so the JMS API, and because I'm lazy, and it's a demo anyway, I'm going to add the server itself. So it's going to embed the server for me for the sake of the demo. So once I have that, I flipped this method to public, and I'm adding a listener to it. And I'm going to say that the destination is book order. And what I'm going to do is, that's going to return the book order status. So the book order status, what's going to happen is, once that thing has run in its own thread, it's going to send a message to some message queue. And the way it works is, we look for, there's a standard header in the JMS spec that's called reply to, JMS reply to actually. And if that header is set, we're just going to use that destination. And if that header is not set, well, you basically have to tell what the default destination can be. And there's multiple options for you to do so. And one of the options is to use the standard annotation send to. So I'm going to say book order status. Right. And I'm going to create an extra method, whatever the name is, that takes a book order status. And I'm just going to, move that away. And create a listener for book order status. And that's taking a status, of course. All right. So then I need to actually process that stuff, right? So I need to send the initial message, so the initial book order, basically, to the queue. So to do that, I need a template. So I'm going to use JMS messaging template for that and just inject it. And even though you see red thing here, because I'm using a underground version of IntelliJ, that's going to be injected properly by Spring Boot. So Spring Boot is going to figure out that you added JMS to your class path. So it will auto-configure a connection factory to OnNetQueue. It will see that OnNetQueue is on the class path, so it's going to embed it. And it's going to create a JMS messaging template on top of it. So then I can basically replace that line with simply this. Convert and send, what's the first thing it takes? It takes a destination, right? Okay, book order and my order. Okay, and because I'm embedding the container, I need to somehow to tell it what queues it needs to create on startup. So there's plenty of options. You can try to OnNetQueue. Is it OnNetQueue? All right. So you can create them via configuration. That's not what I'm going to do because I will use that later in the demo. So I will create a set of beans that defines those configurations. Okay, let's see if it still works. So, yeah, let me first see that it actually works before telling that. Okay, so you get an immediate reply now, and it's sending something behind the scene, and you can see that the book order status has been processed by the message listener. The key point to take into account here is that I didn't change any configuration. I just injected additional dependencies and everything worked out of the box. So let's assume my manager, that's not you, says that JMS is not the right fit for the job and we should use MQP instead. So I need to refactor my code to use RabbitMQ instead of JMS. So let's see what will happen. MQP, anyone? Okay. So if I had that, I basically changed the JMS dependency to MQP dependency, and a bunch of stuff will break. For one, JMS listener is gone, so let's replace that by Rabbit listener. And the queues that you want to listen to. And notice that I'm not changing anything else. So I'm just changing the annotations that that's going to instruct the framework what to do with your method, basically. Okay, and finally, I need to change that. I mean, it's not the way you create queues in RabbitMQ is different, obviously. So just taking the name of the queue. And for the sake of this demo, I have RabbitMQ running locally. I'll show you that somewhere here. So it's basically the same thing. Same story with Spring Boot. If you don't know it, there's plenty of sessions you can attend if you want to know more about it. But basically, now I have MQP on the class path, so it's going to try to set up a RabbitMQ connection factory. And since I didn't provide any config, it's going to connect to the default RabbitMQ instance on your machine. So we don't embed the RabbitMQ itself. So if I post again, that's going to do the same thing, except that it's going to happen over MQP. And that's the only change I have to do to make that work. Okay, so another thing I can show you is if I switch on the Hibernate log, and I try to start my app, then you'll see that every time I'm hitting an endpoint, it's going to hit the database every time. So you can see the select flowing in the blurry screen. Anyway, so let's fix that. And a word of caution here, again, this is a demo. If you need to enable caching in your app, that's probably not that layer you're going to cache first. I just want to show you the developer experience you can get with Spring Boot 1.3. By the way, if you've used that in the past, we had a session with Juergen last year at Spring 1 showing you the new cache improvements. Bear in mind that Spring Boot 1.3 has auto-configuration for it now. So if you wonder where the configuration is, that's because I'm using Spring Boot 1.3 and it does that out of the box for me. So what does that mean concretely is I'm going to add the starter for that. So the cache starter, that's the only thing I need to add for now. And I'm going to say I want caching. So the reason why we don't do that by default is enabling or disabling caching is a decision that you should make. And we shouldn't make it based on the fact that the cache infrastructure is on your project, on your class path. So this is a one-liner. You've seen also, maybe I went very quick about that, but you also see that the JMS listener and Rabbit listener, you didn't have to configure any infrastructure for that. The reason behind it is we configure the connection factory for JMS or MQP, and we also configure a default listener container with sensitive options, with default options. So if you're happy with that, you just put the annotation and it will work. So I need to cache something, right? So I'm going to do that on the repository for the sake of the demo. Repository, I said. And I made that mistake again. That's the book repository. So I'm just going to override two methods, which is find one and delete, and show that you could have, first of all, a new feature in, sorry, font size bigger. New feature in 4.2, I believe. Yes. Is now you can provide some default options at class level, and they will be applied to any cache method you have. Which means that since I've done that, the only thing I need to do is to write this. Okay? And have caching on my repository. Just like that. So you may wonder on which cache infrastructure that stuff is running. So let's see first that it works. Okay, so now on the blurry screen, you only see one line, right? Which is down below here. And for the sake of it, let's show a different one. Okay, so I have an extra select. So if I go on the metrics endpoint, for those who know that, for those who who do not, you'll see soon, then I get out-of-the-box metrics for my cache. So I can see that the size of my books cache is 2. There's the 2 books I tried to load so far. That's new in Spring Boot 1.3. And what's new also is since I don't have any caching infrastructure in my app, well, it's basically try to find one implementation, and there is none. So it's going to fall back to a concurrent hash map implementation. So that's basically concurrent hash map holding those books behind the scenes. But I can do more, obviously. I can do way more. So first of all, I can do this. I can switch to JSR 107, and I can say, okay, I don't want to use those. I don't want to use those annotations. Instead, I want to use those annotations. Cache remove, I guess, or cache delete. Remove. So I'm not going to start it up, but basically what I want you to remember is concurrent hash map is not JSR 107 compliant, right? That's not implementing the spec. We don't care about that. So the abstraction that we have, we don't care if You specify the annotations with Spring's annotation, JSR-107 annotation. You choose whatever you like. And behind the scenes, the cache manager infrastructure take care to talk to either a JSR-107 implementation or whatever native library that we support. We support JCache 2, Hazelcat has a support for it, Infinispan has a support for it, etc. So if I restart that, I can have JSR-107 in your code running against a non-compliant JSR-107 cache manager. But let's add a JSR-107 cache manager to show you the kind of experience that you get. So JCache, they're working on the JCache 3, so I'm going to use the latest milestone, which means now I have a JSR-107 compliant cache manager on my class path, and Spring Boot will find about it and just auto-configure that for you. And what I can do is I can basically customize it before the application starts. So cache manager, customizer. Okay, so let's see what I can do here. I can create a cache, that would be nice, called books, and say that I want statistics on the cache, right? So if I restart, well, Spring Boot is to do its thing and just configure your app on the JSR-107 cache manager. So let's see, it's still showing only one select statement, set 1. And then if you go on the metrics endpoint now, without books, then you get different statistics. You get the hit and the miss ratio. So don't ask me why the size is gone. The size is gone because JSR-107 has no size in the spec for the cache. That's why it's not exposed. All right. So what could we show next? What we show next is some of the things that Juergen has mentioned in the first part of his talk. We have this queue configuration here. And if you remember, the difference between JMS and MQP was really, really small. So let's refactor that so that we can externalize most of the bits. Let's call that MyapplicationConfig, whatever. That way would be better. Let's see that, not in static here. Let's see default method, right? And let's move that stuff to its own method. Create queue. Yes. Yes. I need probably to exclude that. Right. So now I have a configuration class, which is an interface. And I could have something like RabbitConfig that implements my messaging config, right? And the only thing that it does is basically implementing the create queue default there. That's probably totally wrong. Juergen has no mic, so he can't tell my mistake, right? You can hit me, maybe. No? That would work. Oh, yeah, forgetting the tab here. Sorry? Oh, yeah, right. Thank you. Thank you. And that, and that, and that. Sorry. That's probably better that way. And this should be this should be. Oh yeah, okay. I'm totally wrong. Totally wrong. Totally wrong. All right. Thank you. No hit even. It's even better. So it's starting again, and well, you get basically the idea. If I post a book order, that's going to create that for me. So we still have 8 minutes, so you probably have a bunch of questions. So the last thing I want to show you is how you can compose annotations very easily. So if we go back to our controller here, I can see I have a post request mapping on this path. So let's see it's a very, very, it's a use case I'm using very often, and I want to rationalize that for my own needs. So let's create an annotation for that I will call post, whatever. Like some post you may heard of. And let's say this is a post method, right? And rotation type, otherwise nothing works, right? Rotation type, runtime. Then I'm going to say, since the only thing I want to configure here is the path, so I'm going to say value, because that's the keyword you need for the default thing. And now the only thing I have to do is to use this alias for that Juergen explained for the request mapping annotation. And then I can choose an attribute. And the attribute is path, right? So if you're wondering where the auto-completion comes from, told you I was using underground version of IntelliJ, that's why. It's actually coming back in IntelliJ15, yeah. So now all I can do is I can actually do this. And I guess I'll have to prove that it actually works, right? So let's restart that. And push something. And done. It's still working as before. Okay? So that's easy. That's the kind of workflow you could have to create your own annotations. Very easy. And I think that's it. So thanks for the both of us.